Welcome to Going Green, our weekly podcast, having a look today at the Plastic Conundrum. Big word, yeah. So, should we stop all our oil production? A lot of people seem to be very keen on doing that at the moment. Let's turn to electric cars. Let's power them by solar and, probably in this country, wind power. Let's get rid of those horrible coal mines. Let's just use clean wind and tidal power. Sounds brilliant, doesn't it? But what would you wear? You see, plastics are made from oil. No oil, no clothes. Well, no glue. No spectacles. No computers. No cars. No phones.
Oh, no.
My mum went mad. No kitchen units. Worse for her, no tea bags. No batteries. Without some of that, we're going to be stuck back in times before the 1870s. You know, and we'd have big problems about sort of what would we carry our water in? Would we go back to those lead pipes?
Well, the honest answer there is don't be such a what's it? Really, we wouldn't be going back that far. We're probably only going back to the late 1900s. You see, rather than that far. Come on.
So you're not going to worry about having to use hazardous sort of lacquers on the wires. Not going to worry about having no semiconductors. How about no toothbrushes? No paint? There are alternatives to plastics, but that's where we've got to try and come in. So although I hear up in sort of Scotland, there's a new sort of oil field being found, and well, we mustn't go and use that, because if we use that, well, think of just burning it. But that's very short-sighted to think that we actually just burn oil. That's all we do with it.
Well, yeah. Well, you've got to look at what's happening in regards to what do we use the oil for, and approximately, was it something daft like 6% or 7%? I can't remember. It was something very low of all the oil we produce goes into plastics.
Yeah, it is actually quite low. Go in the middle one. There we are. Look, you can see both of us. What we've got is a choice, though. We can use plastics made from oil. We can use plastics made from, well, plants. But what are the problems in trying to make plastic from plants?
Well, incredibly, daftly, it's, well, no, new technology is, you've got your xylene. That's the common plant-based plastic that's out there currently running around and trying to prove its worth. But it's not a very good plastic, and it's very sort of rigid. Basically it can be used instead of polystyrene, but it doesn't fill the role that polystyrene, clothes stuff, polyester.
Yeah.
Doesn't fill the role of polyester. See, there's too many polystyrene,
There's lots of polys.
it's all about plastics, I'm afraid. And so, it's one of those things where we're trying to look up and work out how to transform these plant-based oils into plastics, which is have the same material properties as the plastics we've got currently.
We can do a lot of those, though. We're quite ingenious in that. And let's face it, our two biggest environmental problems at the moment are climate change. And of course, if you want to go to the beach, discovering the sea is basically full of plastic and, well, plastic's everywhere, plastic pollution. And there's no question about these two things causing the basic problems with our lives at the moment. And it's going to require a lot of innovation and probably an awful lot of action to try and do something about that. People don't want to do things. Plastic pollution and climate change aren't really separate, but they're very closely linked because some of the plastics are causing sort of huge amounts of emissions.
Yeah, and I'm not disagreeing with all those things, you know. And unfortunately, we've just gone through we're at the ends of the pandemic, the coronavirus pandemic, and so because of that, everybody's had to wear all the masks. But at the same time, all these masks had to be made disposable because, of course, you can't reuse a mask if it's contaminated with coronavirus. So obviously, that has to go away. However, you know, majority of masks aren't, and they're the ones that are being, you know, the single-use ones, and are being thrown away. So suddenly, you know, people are discovering all the masks as all these single-use ones all over the place, and they become probably nearly 50% of all disposable plastic waste. You know, at this current time, yeah, it's just one of those things where it just happens to be. But of course, those masks are built to be tough, to resist, and to stop not to be destroyed by anything, because of course their role is to prevent you from getting ill, is prevent things from passing through it. It's yeah, it's one of those odd things where the reason plastics were so useful, are still so useful, is because you tell me a material that can fit those properties that plastic has, and the obvious answer is
You can't.
you can't find one.
Yeah. But one way, of course, is that all this plastic's going to end up in a landfill, or you could actually use it. And we've had discussions before, Paul and I, about this idea of, well, burning it. Some places actually do burn the plastics. The problem is that produces toxic gases, and it's going to produce an awful lot of carbon dioxide.
Yeah, it's one of those unfortunate things where, you know, because plastics are basically hydrochain carbons or complex hydrocarbon chains, and they can burn, but they don't burn well as fuel. Surely then we can burn them off instead, which is what we do, rather than requiring fuel, which essentially is avoiding the problem of them in the landfill, putting all the, you know, not decaying for the 400 years. So basically, it's more removing them out. But yes, they transform into all the gases, but it's not actually too bad. It all depends on what plastic is being burned. If it's relatively, I say, clean plastic, that's not quite the way I'm thinking it, but relatively clean of very complex, I wouldn't say molecules, you know, we're talking things like fluorine and other chemical, elements like that. You see, then they just burn to produce CO2 and water, which then leads into the ultimate thing, an ultimate goal, which lots of investments are going into, is this, I say, silver bullet, but you know, it's more of a black bullet, is carbon capture, where if you are just burning, or if what you're burning is just producing CO2, then you can just not filter out the water, because water's easy, because water goes away, but and that leads to the carbon capture technologies, which is easy to use because it's all the development going into that currently.
But that also requires, I don't know, some of this carbon capture isn't as clean and wonderful as people say.
Oh,
now there is the sort of other problem though with this. I was watching a little TV program, and I was watching this on recycling aluminium cans, and I thought, oh, this is good. Until you look at what's in an aluminium can, and what's in an aluminium can
unfortunately, it's a thin plastic film. So they put the aluminium sheet, they put some plastic over it, and then they roll it into the can. Well, not quite like
And
that.
if you recycle it, then you've got this horrible amount of plastic in there as well.
Which is why, although they tell you you can recycle your aluminium cans, and aluminium cans are very good at recycling, they're not. Because what really happens is they melt the aluminium down, and all that plastic basically just gets burnt off,
Giving off CO2.
giving off the CO2. So, yes, they're recovering the aluminium, but they're not recovering the plastic.
So this is a problem when you even want to think you're going to recycle. Recycling, you think aluminium cans was going to be nice and easy. But when you come to recycle plastics, the big problem that I see is that some things that you buy are a mixture of plastics.
Yeah, it's because they've got different, as I said,
Different properties, and some are recyclable and some aren't. And if you've got an item which has got a mixture of both, then basically you can't recycle it.
Yeah, there are lots of people being very finicky about recycling, but a lot of it is actually at the recycling plant. They have to do a lot of sorting because, of course, each different type of plastic or those has to have a different method of recycling. So basically, they need to sift it through, and they try to lump together the same types so that it's more efficient on their recycling path.
Which is why you see now so many packages with a little printed thing on it, either molded in the plastic or printed on it, which says what type of plastic it is. And that makes it easier to recycle.
Yeah, it's I think it's like a 1 to 10 with 10 definitions, and it's a triangle. That does it.
Recycle to sign, yeah.
Yeah, it's one of those things where it was part of an initiative to help the plastic recycling come through. But yeah, it's a tough thing to say about this. All the plastics, because of course they're so wonderful and so useful. It's just a shame that they are so devastating to the environment.
But I think we have to try and put the sort of burden, the onus on people, just as this country now does the sort of coronavirus. They say, right, we haven't got any rules. It's now up to you if you want to wear a mask. If you want to use plastics, then it's up to you to recycle them properly.
Well, and this is one of those interesting arguments that I don't think is actually quite right. So one of the major things is, of course, producers do put their plastics, they put the numbers on so they can be recycled. But of course, with the combination of, if there are two plastics, you've got to, on the consumer, they've got to sort it out separately there, and then it can go to the correct place for recycling. Instead of putting, say, well, do you need a film? Yeah, we got a couple of parcels this week, and it came in a nice cardboard box.
It's actually the camera that we're looking at at the moment. Hello, camera. Yeah, it comes in it's a nice little black magic camera, beautiful cardboard box. Everything was cardboard apart from
it came in a cellophane wrap, really. Now, I'm not blaming the use of the cellophane, because obviously I understand why the cellophane was used in the first place. I'm just saying it came in a box.
But we couldn't recycle that, could we?
We couldn't recycle the cellophane. Which is the issue. But of course, it did come in a cardboard box, which of course is recyclable. And what was the job of the cellophane in respect to the job of the cardboard box?
Yeah, trying to keep it, in case it just had a little bit of water on it, that would keep it off and protect it.
Yeah, which I understand. Yeah, as I said, I understand the job of the cellophane.
And it comes in the UK, and you'd expect it to sort of, I had to try and get it from the shop to the car, and it was raining. Not much, but it was raining enough that we had a few spots on it, and if we wanted a bit more, then the box could have got wet and the goods inside could have got damaged.
So, yeah, it's one of those niggly points I find, is that what was the point of things?
Well, they could have put a layer of plastic on the cardboard, which is quite a popular sort of system, And of course, that is actually worse than the situation we had. We had a small amount of packaging we had to throw away, whereas the rest we can recycle. And I'll probably see it when I buy my next Black Magic cap. Well, it won't actually, because that's Australia, but it'll
Yeah,
come when I buy my next sort of item from the UK.
yeah, transform. So it's one of those interesting things to sort of look at. It's sort of, if you put that layer of plastic onto the cardboard box, the cardboard suddenly doesn't become recyclable. So having, instead of doing these mergings of materials, having separate layers of material is actually more beneficial than if not. So that's a way forward. Not necessarily stopping the plastics, but helping to deal with them.
Well, I am noticing that more and more these days, everything we buy comes in basically what I would regard as an egg carton. I know it's not an egg carton, but it's that cardboard that's been squelched and squashed and molded into a shape. And it's much better than having my hate of my life, the polystyrene, which in theory is recyclable, but in practice, most places won't take it.
So yeah,
It's too hard, isn't it?
just too hard, but it's all right. It's not too bad. So moving along from these sorts of plastics, you're looking at sort of what can we do instead of plastics. We talked about the plant-based
So
ones.
so we got cardboard,
So
which
we got
is
so we've got cardboard, as you just said, which is it's fairly robust. It does everything that most plastics do. It's rigid. And we can use it, and it is. I wouldn't say 100% recyclable.
so then the other one is plant-based stuff. You can go for some sort of plant-based
Well, this
sort
is
of
xylene stuff.
yeah, but not even that. There are you're not limited to xylene stuff. You can go to a whole range of different things if you want to.
Yeah, well, yeah. You just need
It
to
just costs more money.
It just costs more money because they're not set up. It's the volume and scale of which they're set up. They're bespoke things at the minute, but if we move them to the mass market, suddenly it's mass market prices.
The difference is between plastics made by a plant and plastics made from oil is plastics tend to be what I would call batch based. I grow the plant, I do something with it, and then I take another batch of plant and I do it. Whereas the oil, you can sort of feed it in and it just comes out almost continuously. More efficient for industry, cheaper than the plant based. And if you're given a choice of two products, one expensive and one cheap,
Like
and they're identical, which one are you going to go for?
exactly.
It's the one I go for.
Well, yeah. So it's one of those things where we can't do anything, but it is that continuous thing of continuous production. You talk about the problems of the oil drilling. You ask, all right, what's the problem of all the oil that's going out and the not happening? And most of that they said wouldn't be used for burning. It's like the coal plant that's just been released. Well, not really released.
You haven't got the buttons down to an art, have you?
No, I
Yet?
know, because you changed them all.
I'm sorry.
Because you want to do it your way, not my way, and I'm the one controlling it. Anyway,
We'll get on.
we'll get back. So, the coal plant, they said, oh, hello. A third contestant.
We have a third entrance, yes.
But, the coal plant, well, I can't remember. It's down in something like, is it Cornwall? No, it's not Cornwall.
No, I can't remember
I
where.
can't remember where.
Go where?
Anyway, 90% of that is not going to be used, well, and any of it's not going to be used for
Burning. Yeah.
It's going to be used to make all the graphene and graphite products that, funny enough, require coal. And instead of getting coal from who knows where, you can get the small amount of coal which we need here in the UK. It's about supply and demand.
Yeah, we are a country built on iron and coal and surrounded by water and a bit of oil and gas. and it's fantastic if someone put all those things together with a little bit of thought instead of just sort of doing it. It's sort of coal is not designed for burning. So since it's not really designed for burning, let's use it for what it should be used for.
Yeah.
And if we can do that, things will be great.
Yeah. So in talking about the landfills, of which lots of plastics are going, you hear the common things where something like it was wasn't it Greenpeace said like 50% of our plastics being sent out to Turkey and then just being dumped.
Yeah, this is one of the problems. Our recycling. Sometimes we do our little bit and we clean our plastics. We put it in the bin. It used to be we had them all separate, but our councils decide, yet no, they've got. I saw lasers. I still don't understand why. And they can then sort them out into the different bits, and then they pop them off somewhere, and they export it to a country where they landfill it, or they don't, and it just gets chucked in the sea.
So yeah, and you sort of go. So we did our part. We recycled. We took our plastic, we separated out, we did all that stuff, and then we passed it on to another country, who were willing to buy it for a premium. We were paying. I think we were paying Turkey to do it because they wanted to develop their recycling, and it was as an investment. But of course, they didn't actually process that much plastic, so we were trying to help them out, and
Yeah.
lots of complicated deals in happened. Anyway, but of course, what happened was that Turkey didn't use that money we gave them to recycle or to build recycling plants and all those sorts of things. They took that money and who knows what they did with it. And then just, of course, they had no money, so they just
Yeah.
dumped it, which is because they didn't have the infrastructure to deal with the plastic because, of course, they squandered it, which is a whole.
It's a big problem of our time here, isn't it? So what do we need to do? We've got to worry about any plastics that go into landfill can actually end up in the water, because the water goes through the land and goes out to the sea, and the plastics get broken down, as well as some people that decide that plastics need to be dumped in the sea. And just looking around the seashores, you can see how much gets dumped in the sea. But the plastics do get then broken down. Unfortunately, then they become microplastics. And then the fish decide, well, little crustaceans decide, oh, that would be nice to eat. And the fish say, oh, that's a nice crustacean. And so the fish eat the crustacean.
Yeah.
And then the fisherman goes out fishing, said, oh, that's a nice bit of cod, And so I now have a nice bit of cod or salmon or whatever it's going to be. And now I've got microplastics.
Which is a whole problem because, of course, you can't, or right down to the crustacean level, cannot process the plastic. So it just lives in you forever, effectively.
So there we are. How about what can eat plastics? Now, when I was at uni, there were some bugs discovered, and there was a lot of worry about these little bugs because it wasn't they could eat plastics, they like petrol, and these little bugs would eat petrol. And there was a lot of worry about these little bugs. If you got them into the petrol, then we could basically just get rid of all the petrol quite easily. There are, you were telling me, some wax worms.
Yeah, I can't remember if they were actually truly wax worms, or at least a family of the waxworm. But effectively, and I've just read it up, it's Indian mealworms.
Oh,
Very exotic. And basically, they can eat, chew, and digest the plastic. Yeah, we're talking very basic plastics. Think polystyrene and those sorts of ones. And them digesting it are able to essentially process it into manure, basically insect poop. Now, manure is so much easier because you've gone from a complex hydrocarbon chain, which forms plastic, to a very basic one. Essentially, which suddenly you go from isn't water soluble to is so water soluble you don't want to know.
Yeah.
Which is a surprising thing in regards to how all these things where adaptation of the mealworms have gone through. Yeah, but not that we haven't trained the mealworms though on to eat it. It's just they've got an enzyme or something in them that
They can do it.
they can do it. And the other thing is, of course, they're pretty much resilient to most things. You just look how easy it is to grow. So an attempt was made of on a small scale was to introduce these mealworms into or onto landfills to see if they can reduce the plastic and actually help the microbial life who eats, fun enough, their manure. And suddenly you've now gone from a very unhealthy landfill or a biosphere in the landfill to a landfill biosphere that can actually cope with the requirements of the conditions that they're in.
And that's good. And of course, if there's any starlings around, if they're from, like in my garden, there aren't any mealworms after a few minutes. They sort of go mad over the things.
Well, yeah, but we're talking about what they actually do. Reading from the report is they dig a small trench, they put the mealworms in, and then they cover them up.
So that will try and stop my little starlings
That'll
having a
stop your
go.
starlings
Yeah,
from
yeah.
going,
Oh,
yeah.
fair enough. Okay.
And the reason doing is because mealworms don't really care about light. They just need air, which isn't so.
Yeah. But I know that I've done some work on plastics, and one of those was to use a different plastic, PLA, polylactic acid, and that is very biodegradable. So much so that when we buy some of those things, you leave it around sunlight or whatever, and you basically you pick up this little bit and it sort of just falls to bits. Uh, Too much is obviously not a good idea, but if you can mix the polylactic acid with others, you can make plastics that aren't biodegradable into plastics that are biodegradable.
Hmm.
And that's quite useful.
Oh yeah, because because obviously once that we've degraded them, as in from a complex to a simple, processing a simple, I say plastic, but it really more of just a
Hydrocarbon.
going from that is so much more easy. And even better, we can use those simple chains to make other complex chains. So this is the whole feedstock approach to plastics as opposed to the normal sort of reusability, not reusability, the just having to destroy them.
Yeah, or in fact just recycle. I suppose the first thing is when it comes to plastics, can we reuse them? My wife says I reuse all my t-shirts and whatever for years. Then can we, if we can't do reuse of them, can we recycle them? And if we can recycle them, they can be turned back into a different plastic. And then when they get to the end of their life, can they then be basically broken down by your mealworms, bacteria, something else? And if we can do that, that will sort of improve the situation. Well, we've come to the end of our half hour. So thank you very much for listening or watching if you're watching our YouTube. And we'll talk to you next week, when we'll look at some more issues about going green. So it's goodbye from me, and
I presume it's a goodbye from you, but I'll get it right eventually.
goodbye.
Bye.